Tabular foundation models like TabPFN are redefining few-shot learning, but they have a critical dependency. Their predictive performance is entirely driven by the labeled context set you provide at inference. If you select poorly, accuracy collapses. But what if you have 0 labels? This cold start problem is where standard tabular selection fails. Raw tabular data lacks a reliable metric. You're dealing with heterogeneous feature types, incompatible scales, sparsity, and nonlinear interactions. Euclidean distances in this original space don't align with predictive similarity. In fact, as your labeling budget grows, selection in raw feature space consistently falls below random sampling. The fix isn't a more complex algorithm. It's a better representation space. LUCoS, Latent Unsupervised Context Selection, solves this by projecting unlabeled training data into a latent geometry induced by an unsupervised prior-fitted network. We specifically use the PIN encoder from TabClustPFN, which maps each instance to a 512-dimensional embedding where cluster cohesion and predictive structure are preserved. Once embedded, LUCoS applies K-Medoids under Euclidean distance. We use Medoids, not centroids, because Medoids are actual training instances, making them directly annotatable by an oracle. Evaluated across 67 OpenML CC18 datasets, LUCoS ranks first at every labeling budget. But the mechanism is the real breakthrough. A gain decomposition reveals a regime shift. At 1 instance per class, performance comes purely from K-Medoids enforcing coverage. But from 4 instances onward, the selector's contribution plateaus, and the latent representation becomes the dominant driver. It actively rescues datasets where raw space selection fails, proving that unsupervised context selection depends less on selector sophistication than on defining representativeness in a meaningful latent geometry. Because inference is decoupled from selection, LUCoS integrates seamlessly into the TFM pipeline, reduces the quadratic cost of in-context learning, and establishes a new baseline for label-free few-shot tabular learning.